All right, we'll go ahead and get started. Thanks a lot for coming. You guys made it through the entire summit, all the way to the last session, so I appreciate you guys showing up, and congratulations. Hope this was a wonderful event for you. So we get to spend a little bit of time talking about one of my favorite topics, which is around IoT. So I want to talk with you about a couple things today as we take a look at this particular topic. One is I want to spend some discussions just tying into the overall theme that you guys have been hearing about here at the summit all week in terms of this journey along digital transformation that all of our enterprises and businesses are going through, and what is the role that IoT has to play as part of that overall transformation. And then the second thing I want to discuss with you guys is around, as we take a look at IoT, what are the things that we envision happening from an implementation standpoint, from a future direction standpoint. So as you start making your plans around this particular area, what are the things that you need to keep in mind from a strategy standpoint? So those will be the two topics that we spend a little bit of time discussing around. So let me go ahead and just set the context again, because as I mentioned, the overall theme that we've been hearing about here at the Red Hat Summit is all around this idea that we are undergoing massive, massive disruption and change across our enterprises and across our entire industries. And a lot of this is being driven by the fact that our enterprises are all turning into digital enterprises. Now, if you take a look at these four companies up here, what do you think that they have in common? Well, first off, these are all relatively new companies. All of them are within the last 10 years when they came onto the scene. But the other big thing around them is that these are all digital-first enterprises that have come into very, very traditional enterprise spaces. If you take a look at Uber, Uber is now the world's largest taxi company. They don't own any of their own vehicles. Their value proposition is entirely digital. Facebook, they're the world's largest media company now, but they don't produce any of their own media. Their entire value proposition, again, digital. If you take a look at Alibaba, Alibaba is the world's largest retailer. They don't own any of their own inventory. Instead, the value that they provide is how do we give digital capabilities around goods and services that you want to purchase. Same thing with Airbnb, world's largest hoteling chain now. They don't own any of their own real estate. All the value that they provide is digital. So this is the new world that we're going into. And so the question is, what do we have to do as we consider our own industries to be able to shift into this new world? Because everything is transitioning from, what do I own? What do I offer my customers from a tangible standpoint into how do I offer digital services? Now, there's three things that you have to start to take a look at if you're going to start to transition your enterprise into this digital realm. These are around mobile, around IoT, and around cloud. And these are three big areas that we focus on a lot at Red Hat, because when you think about mobile, this is how you're going to deliver the digital value to your customers and how they're going to experience it. Mobile is going to be the primary interface where your customers will start to engage with you from a digital standpoint. IoT is arguably the heart of what happens around this digital transformation, because IoT is where you will take all your existing analog businesses and connect them to this new digital world. And then finally, cloud is where you're going to run all these new digital services. And so these three things happen, hand in hand together. You're not going to be able to talk about IoT without thinking about mobile. You're not going to be able to think about mobile without talking about cloud, because all of these come together as part of your overall digital transformation. And so as we take a look at IoT together, this is going to be the topic we deep dive into, but it's important to understand that IoT is part of a bigger overall transition that is happening across the industry, which is how do we start to take our existing businesses and turn them into digital enterprises. Now, before we deep dive into the particular topic of IoT, there's one other high-level thing that I want to reinforce, which we've been talking about at the summit this week, and that's the role that open source plays. Because as you've seen time and time again, whether in the keynotes or whether across all the different sessions, every single major technology initiative now is being driven first and foremost by open source. And IoT is no different. And you'll see as we take a look at all the different technologies that we talk about from an IoT perspective, you cannot do an IoT implementation today without taking advantage of where open source is leading you. And so as you think about how do I go towards this digital future, how do I start to implement an IoT strategy, one of the important things that you're going to have to think about strategically is, how do I start to adopt open source in a more intentional and strategic and sustainable manner? Because whether you do it intentionally or whether it just comes across you, as you get into the space of digital transformation and as you get into the space of IoT, you will inevitably be dealing with open source technologies. So that's the overall context. So let's go ahead and deep dive into IoT now. And as I mentioned, IoT is arguably at the heart of digital transformation because IoT is how you're going to connect all your existing analog businesses to this new digital world. Now, when I say IoT is at the heart of digital transformation, you can really quantify that with two different perspectives. Now, I've got two different data points up here, but they both reinforce the pivotal role that IoT is going to play as part of this overall digital transformation. On the left-hand side, you see a chart in terms of all the things that are going to be connected to the internet from a device standpoint. And you can see by the year 2020, according to Gartner, there's going to be close to 25 billion different devices connected to the internet. Now, contrast that with the entire human population, less than 9 billion people. Now, the ramifications of that are huge, because what that tells you is that as you build new digital services and new digital capabilities, the primary consumer of these things are no longer going to be human beings. They're going to be primarily machines and devices. And so all the things that we think about today in terms of how do we build compelling applications, now you've got all these UX designers, you've got all these people who care so much about design. These things are still going to be important, but only for a minority of the population consuming your applications. Going forward, it's going to be much more driven by APIs and services that are consumed by other automated systems or other digital devices and capabilities. That's going to be a huge, huge shift in terms of how we build out our applications and our architectures and our infrastructures. And it's all going to be driven by IoT. On the right-hand side, you can see an economic quantification of this big change that's about to happen across our industry. This was a study by McKinsey projecting what is going to be the economic value around IoT as we take a look at the next 9 or 10 years. And they project that by the year 2025, the entire IoT market is going to be worth in excess of $11 trillion. Now, if you take a look at that number, I know it's a very big number, but this is greater than the entire GDP in 2015 of the country of China. So it's like all of a sudden a new China appears, plus some extra economic value that is going to be created as we make this transition to IoT. And the reason that this is going to be such a big opportunity, even bigger than mobile, even bigger than cloud, is IoT is about how we take every single existing thing that we're doing in the world today, every single analog, every single physical device and business, and we're going to connect them to the internet. And when you go through that, that's going to be involving a lot of massive spend in terms of how do we deal with that. And it's also going to create all sorts of new opportunities as we take a look at this. And so as we take a look at IoT, it's already coming, it's going to be huge, it's going to be massively disruptive, and it's going to reshape everything that we do. So what I want to spend a little bit of time talking with you about today is, as we go through this transition over the next few years, what are some of the things that you're going to have to keep in mind as you start to think about how do we implement our own IoT strategy? Now, in order to address that change, there's sort of 3 topics that I want to dive into, because these are the things that are shaping the direction of what is happening from an IoT perspective. Now, the first big trend that is shaping the world of IoT is the consumerization of IT. Information technology, this is where most of us work today in this particular industry, and we're all familiar with it, but there's a lot of trends that are shaping the consumerization of IT that are going to affect the Internet of Things. Second big trend that's shaping what happens from an IoT perspective is the digitization of operational technologies. We're going to take a look at all the new things that are happening from an OT perspective, because that's going to have a big influence in IoT. And then finally, these two worlds are going to converge in a way that have never converged before, and that ultimately is going to lead to the final area in terms of what is going to be the ultimate fulfillment of IoT. So I'm going to dive into each of these 3 areas in a little bit of detail. First, we'll spend some time on the consumerization of IT. Now, all of you are familiar with what's been happening in this space, and I think the best way to describe what's been happening around the consumerization of IT is to think about what's been happening in each of your own personal lives. Now, all of you have lived with enterprise software. You go to work and you deal with it. You log into your systems on your laptop and your browser, and then you all go home at night, right? And you log into your own personal IT departments on your phone. I can download an application. If I don't like it, I delete it. I install something else. And this is a radically different experience than what I experienced, in my typical workplace environment. And mobile technology is where you can start to see very, very clearly what is happening around the consumerization of IT, because you're starting to introduce all these new technologies that were introduced first from the consumer standpoint and now driving new enterprise value. Now, we've been taking a look at Red Hat in terms of how we work with our customers around the adoption of mobile, not from a consumer standpoint when we all go home at night, but what happens to enterprises when they start to adopt mobile-first technologies in terms of how they interact with their customers, and then also in terms of how they interact with their own workforces. And we commissioned a study, and we took a look at what were the results of that, and it was very interesting. And so you can see the data up here, and I'm going to summarize it for you. Basically, if you take a look at what happened, the first dramatic increase was that if you take a look from a revenue standpoint, what new business can we start to expect from our business as we start to engage with our customers in a mobile-first fashion? And what we found was that you start to see meaningful increases in your revenue. So 19% increase of services revenue, 13% increase of new sales. And so meaningful business that you're starting to generate net new because customers want to engage with you more through their mobile devices than through traditional forms of interaction and through traditional channels. Other interesting and even more impactful change, though, was when you take a look at what happens when you roll out mobile technologies for your own workers and what happens to their productivity. And you can see that, both from a productivity standpoint, 63% more productive in terms of what your workers are able to achieve, but even more significantly, they're much happier when they come to work because everyone likes to use their phones much more than all the cumbersome traditional systems we've all lived with. And so there's a twofold effect when you start rolling out mobile technologies into an enterprise standpoint. Yes, you can generate a lot more business, but even more fundamentally importantly, you make your business much more productive and much more efficient in terms of how you roll out these capabilities. So the question becomes, okay, if I want to implement these new consumer-led technologies from an enterprise standpoint, how do I actually do that? Because I have to think about how that affects every single aspect of my IT architecture. Now, if you're going to roll out new mobile technologies or other things that are related to consumerization, think about the dramatic impact that's going to have across the way that you do IT and everything that touches it. So, for example, think about the release times for your applications. Typically, you're dealing with maybe 18 months, 24 months release cycles in terms of how often you do an update from an enterprise software application standpoint. Now, think about how often you update applications on your mobile phone. You're probably getting multiple updates of applications every single day that you're dealing with. Now, if you're going to be able to deal with a new application architecture that is able to support these kinds of daily updates, that means you're going to have to change everything about the way you build your applications and you run your software. This is really important because if all you do is I take my existing application and I just wrap it in some kind of HTML5 interface and I put it out in the hands of my customers, they're not going to be happy with it. So you've got to be able to build applications that are natively mobile. In order to do that, I've got to be able to re-architect and retool my applications so that I can start to bring them to market much quicker and have much faster release times. That means I need to implement new capabilities like DevOps. How do I start to build my applications, get them continuously out to my customers in a way that I haven't had to before? Means I'm going to have to retool my application architecture and even my infrastructure systems. Because if my mobile users are starting to come and interact with my applications much more frequently and across a wider range of devices, that means the scalability of my infrastructure is going to have to deal with orders of magnitude more interactions than they do today. It also means that I have to deal with much more responsive systems, application architectures that are much more engaging and responsive rather than transactional. And so when you start to implement mobile and consumer-oriented interfaces across your applications, this is not just a new form factor where I release my existing application. Fundamentally changes everything about the way you build, design your infrastructure and your applications. And so the consumerization of IT has dramatic effects around how you deal with everything from an IT standpoint. Now, one of the things that we've been doing at Red Hat to be able to support this transition is that we've actually been introducing new application platforms to support this new style of application building. One of the things that we have in our portfolio is the Red Hat mobile application platform. And this provides 3 high-level capabilities to support a lot of those enterprise requirements that I was speaking about earlier. First thing that we provide is all the back-end infrastructure to be able to run all your mobile services. Now, first off, this is a cloud-based, container-based system, runs on OpenShift, and so it takes advantage of all these new capabilities that you've been hearing about at the conference all week. But on top of that, we provide a lot of rich services that are oriented towards these new mobile and consumer devices. So for example, how do I do push notification? How do I do synchronization across different devices and data sitting in the cloud? These are all higher level services that my new applications are going to depend upon, and we provide all the back-end capabilities to power that. Second thing we provide as part of our mobile application platform is the ability to design your application once and then deploy it in a native format, whether to iOS or whether to Android or HTML5 and so on. But how do I design these new rich interfaces from an application standpoint? And then the final thing is we provide an interactive workspace that supports DevOps workflows. Because as I mentioned before, you need to be able to write these applications and get them to market much faster than you've ever been able to do before. And so we support all the different pipeline and interaction workflows around how do I create these applications, back-end and front-end, create an interactive experience across my developers and my operators, and get that to market much more quickly. Supports the technology and also the patterns in terms of how we build out these new applications and services. So one of the things I want to just illustrate in terms of if we're going to start to take a look at this consumerization of IT, what does that look like from a very traditional industry standpoint? And one of the most traditional industries and most heavily regulated industries of all is the healthcare industry. Now, one of the customers that we've been working with at Red Hat is Bay State Health. They're a healthcare provider from my home state of Massachusetts, and they've been working with Red Hat around how do we start to deliver these new consumer-oriented digital capabilities to 2 constituents. Remember, I spoke at the beginning. We want to service our customers better with mobile technologies. We also want to make our workers more productive. And they wanted to do the same thing as well. First off, they wanted to provide a new mobile platform for their doctors and healthcare providers so that when they treated patients right on their phones and other tablets and mobile devices, they could get interactive access to new information to support their diagnosis in terms of how they interacted with their patients that would make them much more productive in terms of being able to offer quality healthcare. Now, the other thing that they wanted to do, though, was that they wanted to improve the experience of how patients could interact with the healthcare providers. And one of the interesting things that they built out was a new service where, let's say you're at home in the middle of the night and you're not feeling well, or maybe you injured yourself in some way. Instead of having to get up in the middle of the night and drive yourself to the emergency room, you would be able to take up their new mobile application, take a video of yourself, and get remote diagnosis with your healthcare provider to figure out, is this something that's really serious? Do I have to come in now? Can I wait until the morning? What should I do about it? Now, a lot of you will probably think, okay, that's great. I built a video application. I can communicate with someone else. What does that sound like? It sounds like Snapchat, right? So what's so special about that? Well, remember, we're talking about the consumerization of IT into an enterprise context. So within the healthcare industry, it's not just about the fact that I can have video connectivity. Think about all the regulations in terms of HIPAA regulations and doctor-patient confidentiality, all the protection around medical records and who can access them. How do I take that diagnosis information and then put it into the rest of the patient information and records? So there's a huge amount of enterprise integration and systems that have to be built into an enterprise system like this when you're dealing with the healthcare industry. But we still want to provide that consumer-like interaction because this is what our customers are looking to expect. And so these are the new kinds of things that we're going to have to be delivering as our industry evolves. Consumerization is going to change everything about the way that we build our applications, down to how we run our infrastructure, down to how often and how quickly we release our applications. And this is a fundamental shift in terms of how we deal with IT, and it's going to have a big, big impact on IoT, as we're going to see later on. So that's the first big trend that's going to shape IoT. consumerization of IT. Second trend I want to talk about that's going to have a big impact is around the digitalization of operations technology. Now, I spoke about a very traditional industry earlier in the healthcare industry and how the consumerization of IT was impacting that. I want to talk about another very traditional enterprise industry and how the digitalization of OT is shaping that industry. And in this case, I'm going to talk about the railroad industry. There's probably no industry more emblematic of the industrial era than the railroad industry. These are the things that back in the 1800s that were connecting the East Coast to the West Coast in the US and all other continents around the world. All these steam-powered locomotives that were finally providing transportation of goods and services and people. Now, one of the things that we've been doing at Red Hat is we've been working with the railroad industry for the last several years because going back a few years ago, there was a law passed by the US Congress that mandated the implementation nationwide of a positive train control system, or PTC. Now, this was because there was a catastrophic train accident where another train came in too quickly and crashed. And so as a result of that, Congress passed a law saying that every single train that travels across America is going to have to implement a system where we can remotely track what's happening with that train. If it approaches another train or another station too quickly, we can detect it and send an automated remote control signal to stop the train to prevent an accident. Now, the company behind the implementation of PTC across the US is a conglomeration of a bunch of railroads working together through an organization called MeteorCom. And MeteorCom has built out this PTC system on top of Red Hat. They've been using our operating system, Red Hat Enterprise Linux, as well as our middleware services around messaging to go across a proprietary railroad network to be able to provide remote detection of where all the different vehicles and stations are, as well as the remote control across these trains. And this has been a very successful implementation. One of the things we're most proud about this system is that they've been able to achieve a 99.999% reliability across this deployment. And this is crucial because what we're trying to do is to save lives. Now, you would think that, great, we've been able to implement this system. It's built on top of open source technologies, and we're super happy about it. And it's all good, except for the fact that last year, this was in the news. I don't know if you guys saw this, but this was a really big accident that happened in the Northeast Corridor where Amtrak, the major train line, had a catastrophic accident where a train was going around a bend too quickly, derailed, killed a whole bunch of people as part of that process. And one of the big news items was, even though PTC had been mandated by law and they were supposed to implement it, even though the technology was already there, they hadn't deployed it yet in this particular train line. And so one of the big topics was, if they had implemented positive train control, could they have saved all these lives? And the answer was most likely yes. And so this is where you start to understand what is the dilemma of the digitization of OT. From an operations technology standpoint, we have always been used to the fact that I can put a system in place for 20 years, I never touch it, and I don't have to think about it. But as soon as we start to digitize it, as soon as we connect it to all these other capabilities and services, we're going to have to improve them and update them and change them at a speed and velocity that OT has never dealt with before. And that's going to be a huge, huge change. How do we bring all these IT processes and impacts, and not just old world IT where we've been updating every 24 months, but this new consumer-led IT where things have to change very, very frequently, and how do we bring them into this world of OT? Because if we don't, we can have the best technology in the world, but it doesn't matter if we can't change the way that we update them and the speed at which we connect these digital services. Another example of a very traditional industry where you're starting to see the effects of digitization. If you think about our power industries, we've got all these different power plants that are around the world. Many are coal-fired. Some of the newer ones are dealing with hydroelectric or maybe nuclear or something like that. But these have always been just entities unto themselves. You light them up, you power a grid of electricity, and you're able to serve a lot of constituents. But these are all starting to become digitally connected as well. And so you start dealing with all sorts of different environments where people are taking a look at, not only do I have a power plant, but now I'm going to start to distribute my ability to generate power across all sorts of different houses at a scale and speed which I haven't dealt with before. Take a look at how quickly solar power is being implemented on a house-by-house or a building-by-building basis. They're all putting different power capabilities to locally generate power and store them in batteries. So now power plants are starting to deal with a logistics challenge that they haven't had to deal with before. It's not just I generate my own power and I distribute it to a bunch of different places. Now it's all about how do I become a broker where my constituents are generating their own power and I have to buy it back and redistribute it across a number of different places. That means I have to have new digital electronic metering systems. I have to be able to understand what is my power regulation and demand dynamically. All sorts of new digital systems and scale that I'm going to have to deal with from a power plant industry that I've never had to deal with before. And it's not just about how do I increase my speed and how do I increase my scale from an operations standpoint, but it's also about security. So again, in the power industry, I don't know if you guys saw this in the news. I'm sure you saw the headline news, but there was a big power plant in the Ukraine that was hacked. First time that because all these new power plants are becoming digitally connected, someone was able to come in and bring down an entire power grid in a country. Now, one of the things that was interesting to me about this particular attack was how sophisticated it was. Now, if you take a look at what the attackers did, there was basically a 3-vector attack that they placed upon this power plant in the Ukraine. First thing that they did was they attacked all the monitoring systems. Again, digital capabilities. They brought them down, so basically they were blind in terms of what's happening across our power plants. Second thing that they did was they attacked the actual computer servers that were running the power plants and crippled them so they could no longer offer electricity to all the different places, so you had massive blackouts everywhere. Third thing, and this intersects with the OT side, was that they actually launched a denial of service attack against the phone systems at the power plant. So even as their monitoring systems went down and they were blind, they couldn't even call each other to coordinate how they would respond to what was happening from the attack. So they crippled their ability to be able to even basically talk with each other and communicate from a response standpoint. So these are the things that you're going to have to deal with as you consider the digitization of operations technology. A speed and a scale and a security capability that you've never had to deal with before because all of a sudden everything is connected to the internet now and everything is focused on how we offer digital value. So those are the 2 big trends, consumerization of IT, digitization of OT. Now let's take a look at how they intersect and how they converge around IoT. So first thing that's going to happen is that when you take a look at these 2 trends, they're going to start to converge together from a life cycle standpoint. When you take a look at the consumerization of IT, we're going from an era where it was taking us 18, 24 months to roll out an application, where now you're going to have to go to 1.5 weeks, in terms of how frequently you update your applications. Same thing from a digitization of operations technology, and this is even more dramatic. You're going from a realm where you could leave a system out in the field for 15 years without ever updating it to, again, weeks or even months in terms of how frequently you have to update it. And so the frequency in terms of how you manage the life cycles across these systems is going to converge, which means that the systems behind how you update life cycles are going to converge together from an IoT perspective. Another big convergence that's happening. This is the 10-year anniversary of AWS, which is arguably the first public cloud service that was generally available. Now, what I did was, on the left-hand side, I just wanted to show you this is the capacity of AWS in terms of the virtual machines that you could get in the public cloud when it first launched. And on the right-hand side, you can see the hardware specifications of all these new devices that sit in the field, whether it's a gateway by Eurotech, whether it's a mobile phone by Huawei, or even a Raspberry Pi. And what you can see is that all these new little devices that we carry around with us are more powerful than the computing power we could get in the public cloud just 10 years ago. And this is a huge, huge shift where because there's such rapid hardware advancement in terms of what we can run out in the edge devices and in the field, you're going to start to see a lot of the capabilities that were traditionally reserved for the data center traditionally reserved for the cloud move entirely over into devices that are running in your pocket and little sensors and different devices everywhere. This is going to be another big shift that's happening across the world of IoT because we have this hardware convergence. Now, what that means is that as we take a look at the architectures of IoT, you're going to start to see a convergence in terms of what happens here as well. Now, this is a very traditional architecture in terms of how IoT is being deployed today. You typically end up with a three-tier architecture where you have all the different devices that you guys are familiar with. So in the consumer standpoint, you can think about your thermostats or refrigerators. In the industrial standpoint, you can think about these different vehicles or smart grids and so on. But these are all the different devices. Now, in close proximity to that, you have these different gateways. And so a gateway is basically a device that provides local connectivity for all these different things that are connected to the internet. So you can provide real-time analytics, so you can provide real-time processing of data, and then you broker that into your back-end data centers or your back-end clouds, which provides the connectivity to your overall business. And so these are the architectures today, but because of that convergence around hardware and life cycles, you're going to start to see a blending of how this comes together. I'll talk about that a little bit more in a minute. But one of the things that you should be thinking about is if we're going to have this convergence around IoT, around life cycles, around architectures, around hardware platforms, one of the things that is going to be critical is that how do I start to architect my solutions around IoT? I need uniform building blocks that I can deploy across every one of these aspects that is able to address all these different convergences. So this is where Linux containers, for example, is one of the things that gives us the ability to start to deal with a lot of the convergence that's happening from an IoT perspective. First off, because containers are so small, we can run them on your little device, at the edge. We can run them in your gateway. We can run them in the data centers. You guys have seen all sorts of demonstrations across that from an OpenShift standpoint, for example. But this gives us a uniform building block where now we can have the exact same operating system, the exact same tools around how I update my content, the exact same tools around how I build my applications, and then how do I deliver that uniformly across my IoT environment. And this is really, really important. Let me just illustrate this in one way. So when you build applications today, your developers have finally reached the point where they can have self-service in the cloud, right? This is one of the things that developers love. Now that cloud computing is here, I can go to a self-service portal. I can ask for a development system, whether it's virtualized or in containers, and I get that a few minutes later because I'm no longer having to put in a help desk ticket to get me physical kit to write my applications. Now think about what happens in the world of IoT. If I have to go back all of a sudden, and before my developer can write an application, I have to give them a physical device that is going to be this little thing that sits on their desk, and they have to put their code on there. I've just taken 10 years backwards step in terms of how I can make my developers more productive. And if my developers are targeting all sorts of different form factors, okay, here's how I write my code for the device. Here's how I write my code to run on the gateway. Here's how I write my code to run in the data center. And all these things are going to work together. I have made it hugely problematic for how I develop these applications and how I take them into production. On the other hand, if I build on common building blocks that can run uniformly across all these different environments, I can solve that problem. Because I could do something like I write my application once in a container in the cloud at OpenShift, I deploy it onto a gateway, I deploy it onto an edge device, and I know it's going to work because it's the exact same software stack. So this is one of the things that we've been driving at Red Hat. How do we converge into a common platform that can work consistently across the entire architecture and infrastructure platform? How do I have one set of lifecycle management tools so that as life cycles converge, I have the same platform that I can build uniformly across that? And it's not just from a building block standpoint. You want to be able to take a look at all the features and benefits that come from this common platform and how they accrue to your IoT deployments across every single phase of your deployment. So when you take a look at technologies like containers, they have a lot of benefits. For example, the fact that I can run a very, very small application in a very small container footprint and isolate them from each other as well as from the underlying host environment. That has tremendous value in my data center where I want to run thousands and thousands of containers in a microservice environment. It has just as much value when I run one container on a little edge device and I want to provide security isolation against the host device in terms of how I protect it. It also provides value in terms of if I want to have trusted content in terms of what is running in the container. I care just as much about how I get that content into my data center as I care about how I get that content delivered into my edge device or into my gateway. And so having that uniformity and consistency in terms of all these security practices, all these lifecycle capabilities uniformly across IoT becomes hugely important because everything is going to converge together. It also matters from a management and from an operations standpoint. If I'm going to be able to update things in the field, remember that illustration I gave around what happened with the railroad industry, the fact that they didn't have the mechanisms to deploy their software rapidly enough across their railroad network, and it led to a catastrophic crash. You're going to start to need to bring a lot of the more traditional IT update mechanisms into the world of OT if you're going to deploy new devices and software out into the field at a very rapid manner. So standardizing on a consistent set of management and lifecycle tools, whether in the data center or into your gateways or into your edge devices, is going to be hugely important because IoT services are going to span that architecture. I want to roll out a new capability that has some new code running in my cloud, some new code running in my gateway, some new code running in my device. How do I do that all at once? If my tools can access that fabric uniformly, it makes my life a lot easier and gives me better visibility. And so this is what we've been focused on across our management and lifecycle tools. How do you get that uniform set of capabilities once across everything from an IoT architecture because it's all converging together? Now, I spent a little bit of time talking about gateways and how that plays a pivotal role. I just want to illustrate the fact, using gateways as an example of how we're starting to drive convergence and uniformity across that. And I want to just talk about gateways because this is the part of the IoT architecture that most people are a little bit less familiar with. Everyone here understands what's happening in the cloud, what's happening in the data center. We have an intuitive sense of what runs on our phones or other devices. But a gateway is a device that sits in close proximity to all the things that are deployed in the field. And you can think about this as sort of a mini computer or even a mini data center that's in close proximity to your devices. So the first question is, well, why in the world do I even need a gateway? Why can't I just connect all these end devices directly to my cloud? Well, you could do that, and oftentimes you might want to in a consumer setting. But when you get into an enterprise environment like what we work in, you need a lot more strict requirements. So let's go back to that healthcare example I was giving you earlier from a mobile standpoint. Now think about all these different healthcare diagnostic instruments, and we're all digitizing them and connecting them because we want to be able to hook up our heart rate monitors or our blood pressure monitors and other things to be able to record that information into our healthcare records. Now, if all that stuff is going into the cloud and my internet connection goes down, I don't want to have to deal with a patient scenario where I lose the ability to monitor my patients because my internet connection went down or it became congested. And so that's where putting a local device like a gateway in close proximity to these devices becomes very beneficial because I'm not dependent on a wide band internet connection in order to be able to provide my qualities of service or my real-time response based on the data that I'm introducing into my environment. So a gateway is something I put in close proximity to my devices, can provide me with that immediate response, that higher quality of service, and local interaction with all these different devices. Now, we've been working with our partners. You saw an announcement, for example, this week at the summit with one of our hardware partners, Eurotech, where they have been implementing the Red Hat software stack onto these little gateway devices. And this is our entire stack. Everything from our operating system to our middleware technologies like AMQ for being able to provide messaging and connectivity to the devices. Things like our business rules and Fuse services so we can provide local analytics and rules-based response to what should happen to these devices as they send data. Things like our data grid and storage systems to be able to persist the data that is being collected from all these different IoT devices. And so this entire software stack can run on these little gateways. And if you look at this, you'll notice that this is the exact same software stack we can run in your back-end data centers, and in fact, most of you probably are. And so this is how we are making concrete that convergence across everything that's happening. We can take all that software that runs in your data center and now deploy it locally across your IoT environment. Converges your life cycles in terms of how I manage it, converges your architecture, converges your management and operational capabilities. Now, if I stretch that out across everything that you're doing, from a data center to a gateway to a device, we're not all the way there yet in terms of where IoT is headed from a convergence standpoint. And what I'm illustrating you is sort of the state of the art today. Now, if you look at the data center, and this is across the Red Hat software stack, you can see that every single product we have today, of course, runs in the data center. That's what we had our traditional business. If you look at the gateways, the vast majority of our stuff can run on the gateways today, except for our scale-out cloud platforms. People aren't running scale-out clouds on the gateways yet. And if you take a look at the devices, people are running our middleware platforms, people are running our operating systems, but certainly not something like OpenShift on a little phone or a edge device. But as things start to converge more and more, my expectation is that this will become a shift from the data center all the way to the right, where every single component of a software platform will be able to run uniformly across all these different form factors. Because, again, I showed you the rapid acceleration of hardware convergence, and the power of the devices is only going to get more and more and more. And so as we go forward, it's going to be primarily an architectural decision in terms of what software do we deploy in our edge device, what software do we deploy in our gateway, what software do we deploy in our data center, and it's going to be use case driven and topology driven, not limited by what I'm trying to do with the underlying software or underlying hardware. And this is important because IoT, as I mentioned before, is going to totally transform everything about how we deliver technology. And unless you start to standardize across the entire IoT platform how we uniformly deal with these technologies, you're not going to be able to address all of these different trends that are starting to converge. You're going to end up with my OT silo, my IT silo, and how in the world are these two worlds going to come together? So this is where Red Hat is focused on delivering IoT capabilities. Uniform software platform that can run across everything that you're doing, and how do we start to make that accessible to you from a software standpoint? Thank you very much for coming. Please fill out your reviews, and then enjoy the party tonight at the summit.